The cheapest house you'll build is a square or a rectangle. So don't get into L's, don't get into T's, don't get into U's, don't get into H-shaped houses. So forget that. Your floor plan is going to look like a matchbox on its side. Hello and welcome to the Built Around You podcast. The podcast dedicated to helping you build, renovate, or upgrade your home. Why is building a home so complex and stressful? Why do building projects run over time and budget? Welcome to the podcast Built Around You. So today's podcast is a Q&A. Today we're talking about the walls of your house, the external frame. So whether you're using traditional old style masonry, you're using timber frame, you're using ICF or another type of structure, today is the answer. We'll be answering your questions. So these questions come from Instagram. My Instagram handle is @KieranKMC. If you have any questions, please follow me. I regularly answer questions even during the week. So all your building questions can be answered on Instagram or indeed in this podcast. So first question today is from @McGavin. What type of wall is better and more cost effective to build? Back of the envelope answer, the most cost-effective wall to build is a blockwork wall. So 100mm blockwork on the inner leaf, 100mm blockwork on the external leaf. Now that can change a little bit if you're putting in precast concrete slabs in the first floor. Occasionally you may need to go to 150mm on the inner leaf. On an unusual situation, you might even have to go to 215mm on the inner leaf or even on the internal walls. But that varies wildly on the spans, on the load, on the type of screed you're using, and 101 other different loading factors on the first floor. But to answer your question, the most cost-effective wall is actually a block outer leaf and a block inner leaf, and I'd probably pump the cavities. You're probably looking at a 180mm wide cavity, maybe a 200mm wide cavity. Now that's grand on a flat site. If you're on a sloped site, you could be looking at retaining walls. You could be looking at retaining walls in the house. If your house needs to retain, depending on the site, depending on the complexity, depending on the slope, it may be more cost effective to use a product called ICF, insulated concrete forms, which have an inherent load bearing capacity. They can work as retaining walls. So rather than having to make your blockwork walls retaining or adding even reinforced concrete walls to your blockwork walls and getting more expensive again, in that particular instance, it may be more cost effective to use ICF. But typically I do find ICF costs a little bit more than blockwork on a normal application in a normal non-sloped or flat site. Of course, we know about timber frame. Timber frame costs a little bit more than blockwork in my view, and I've checked it. But of course, it has the benefits of being quicker to get the frame up and dried, a little bit quicker overall on the build, to be fair, and a little bit simpler if you're doing a self-build because a lot of the frame arrives in one go, so it helps you with your setting out and detailing a little bit. But to definitely, in my view, the most cost-effective is block inner leaf, pump cavity, and block outer leaf. And so the next question comes from self-build first-timer. Would love if you could briefly run through how to underpin walls, please. Okay, well, if you're a self-build first-timer, you're certainly getting into a fairly complicated project if you're having to upskill your knowledge in how to underpin a wall. I'm assuming you've netted a bargain in buying an old house, or I hope you knew about it before you bought the house. Okay, what you're doing when you're underpinning a wall, I mean, I suppose, look, let's take it back a step. Why do you have to underpin a wall? Generally, the reason is the ground under that wall isn't strong enough. It may be that the wall wasn't built on particularly good ground day one, although that's quite rare. Or it could be that a leaking sewer, generally a foul sewer, has leaked. Probably an old clay system has leaked, and now all the ground underneath, locally around underneath your wall, has begun to degrade and has lost its bearing capacity. So what you need to do is you need to reinstate the strength of the ground, and then you can repair your wall. So there's a variety of ways to do this. You can inject it with grout. That's generally done by a specialist underpinning contractor. They'll drill into the ground and they'll inject it with cementitious grout. So basically, they're re-injecting strength with a cementitious slurry. So they're putting it's like concrete. It effectively is a kind of very watered version of concrete. They're re-injecting that into the ground to create new strength in the ground that had lost its strength. That's one way of doing it. Another option is to, which we've done ourselves, is to dig down and take away sections of the ground, kind of a hit and miss. So you're taking away, like if you might be taking away section 1, section 3, and section 5 of the ground, rebuilding in concrete or blocks. On concrete, depending on the depth, and then going into the 2, 4, and 6 sectors, if you follow my logic here, or my analogy, and you're reinserting the strength into those intermittent pieces. So it's a kind of a step-by-step kind of approach here, where you're taking out the old ground and putting in new concrete blocks and foundations. That will do it as well. Once you have underpinned it, of course, once the ground is strong enough and has been reinstated with the new strength, irrespective of how you do it, you're back down to the wall. Now the wall will eventually settle back into this new foundation, the new stronger ground, and it's more into repairing the wall. So you might wait typically about 6 plus months and crack repair your wall. So plaster it on the outside, plaster it on the inside, maybe reseal around the window if anything's moved around there, and you're done. But the important is, like, don't just repair the cracks straight away, because the wall will still settle into new foundations locally. So well worth remembering that. And so the next question is from Kian W. Can a timber frame walls be just as good as cavity block walls for holding heat? Can an A2 be possible? To answer your question, 100% they can. Timber frame and block work deal with heat in slightly different ways, in that you have a lot more thermal mass in block work. So if you insulate the cavity of a blockwork wall, you still have your blockwork on the inside and you have your blockwork on the outside, but you're insulating the cavity. So when you turn on your heating, you're heating the inner block because it's still inside the house, and it's inside your thermal envelope because your envelope is in the middle of the wall. So your inner wall takes a while to heat, but it has a thing then called thermal mass. So if you turn off your heating, it'll hold the heat because of the density of the wall. When you have a timber frame structure, you're largely insulating between the studs of your external wall, and you're also dry lining the wall. So you have another bit of insulation on the inside, and you often dry line the wall depending on exactly how the design was done, so that you are insulating over the thermal bridging aspects of your timber frames. Now, some timber frame companies design it a little bit differently, and they use a few different parameters they can get over that, but that's often how it's done. Now, the issue there is the house will heat quicker because you don't have any thermal mass to heat before you get your outer insulation level like you do on blockwork. But it'll also lose heat a little bit quicker because you don't have the thermal mass, you don't have the heat store in your house. That's a little bit of an introduction to all this, but to answer your question, can you get an A2 with a timber frame house? 100% you can. You can get an A1 with a timber frame house. You can build a passive house out of a timber frame house. Like, none of these methods can be used unless they all comply with building regulations, and unless they can all achieve the same U values and thereby the same energy ratings at the end of the day. So whether they use timber frame or blockwork or even a passive house, it doesn't matter. They will all do the same things. They'll all effectively get you from A to B. They just do it differently. And there are pros and cons to using different ones. So you'll always be able to achieve the same thing, but it might cost more, or it might act a little bit differently, or it might hold heat longer, or lose heat a little bit quicker, or heat up quicker, depending on the thermal mass side of it. So there are pros and cons, but definitely you can do the same thing with all different types of frames, particularly blockwork and timber frame, as you asked. So the next question is from Clune de Nair Self-Build. Overall, which is considered the best method for building walls? Block, timber, ICF, etc. We've answered this question a little bit already. I don't think there's any best. Like, I mean, I build 8 to 10 houses a year. I generally use blockwork because it is the most cost effective in the general scheme of things, unless I need to use retaining walls. Because we are a building contractor and we have plenty of experience in building houses, and we're set up for masonry, block laying is the most cost effective solution, and we can offer it most cost effectively to our clients. And I do find that a lot of clients are reasonably traditional in that they just like blockwork. Um, but that's not always to say it's the best thing. I mean, I built my own house last year. We renovated a house. It was an old bungalow, dormer bungalow type house, and it was blockwork on the ground floor. So we extended a little bit on the ground floor, and we kept with blockwork because we were just using the same type of external frame that had already been used. So for continuity, we kept with blockwork. On the first floor, it was getting quite complex, and due to the nature of the site, it was going to be very hard to physically get blocks up onto the first floor. We were also under a little bit of time pressure because we had to move into our house at a certain time, so I needed to make some time savings. And we also needed kind of more the lightweight dynamic aspect of timber frame. So we actually have blockwork and timber frame on our house. Um, so it added a bit more complexity when it came to insulating the house, and when it came to doing the BER assessment, because we had to kind of break it out into different sections. So ideally, it's not the most ideal way of doing it, and my wife wasn't overly keen because we're on quite an exposed site, and she always had a little bit of concern about wind and timber frame. But we've been severely tested over 2 winters now, and it's been perfectly fine. Although it does keep me up a little bit at night when I hear the heavy winds coming at us. But they're like, I do find 70-80% of the time I would automatically default to blockwork. If I was a self-builder and I really wanted something done quickly, and I had something that didn't require me having a load of plant on site. I mean, for example, as a builder, we have a load-all, which is a telescopic forklift on site to lift up blocks. And block layers are hard to deal with as well, masons, because they need dry weather, reasonably dry weather. Then, when you're dealing with mortar, it's a wet trade. You can only work in certain temperatures because if the temperature gets too low, you're starting to come into difficulty with mortar. And you have an awful lot of work in servicing masons, because you have to bring them insulation the whole time. You got to bring them ties. You got to bring them blocks. You got to be there when the block lorry arrives. You got to be there when the mortar arrives. So there's an awful lot of work, and an awful lot of measuring and setting out and checking through drawings and everything else, and all your DPCs and trays and everything else. An awful lot of complexity there, which of course you don't have with timber frame. Timber frame, it's all detailed off-site. There's a warranty for the frame. There's a warranty for all the detailing of the frame. It arrives in a week or two. You have your frame up. If you get the windows ordered as soon as you are ordering your frame, you can have the windows in a week later, and you can get the timber frame company to batten and felt your roof and all. So you can be dried in a matter of a few weeks from your floor slab pour. And there's a huge benefit to that, because straight away you can start thinking about your plumbing and your electrical work. All your internal walls are in place if they're all timber frame, which likely they are. So an awful lot of the head scratching is done by the time the timber frame is up. So there's a huge benefit there for the self-builder, because it just makes it a lot easier, because you're kind of moving away from the drawings quite quickly, because when the whole 3D model is up on site through the timber frame, that makes life an awful lot easier. And it can speed up your program if you're on the ball with ordering windows and getting your plumber and electrician ready and your plasterer ready. And of course, with the timber frame company, you can get your plaster boards delivered and craned into site when they're craning in everything else in through a window open your bedrooms and things. So you have all your plasterboard upstairs. So again, it makes it a little bit easier. But I do find timber frame costs a little bit more. When it comes to ICF, I remember a project we did years ago. Very tricky site, very sloped site, and funny enough, we could only access it from the top down. So we brought diggers down, we dug away the bank. So then we had a steep drop into the site, very hard to get materials there. We weren't going to be able to get blocks down there in any great quantity, only by hand. And we ended up with a very complex situation. I remember we used ICF for a significant portion of the project because it was all retaining, and the only way of getting all the ICF walls down there was walking them down by hand, which is very easy with ICF because these are lightweight blocks, very easy to lift because they're insulation on the inside, insulation on the outside, and we're able to pump concrete down into them, so they worked very well. And they were also retaining, and that's the benefit of ICF. It has retaining aspect, and it's also an insulating aspect. And we were able to get a specialist contractor to do it. And we also managed to get a level of timber frame down because the front of the building didn't need to be retaining. So we got a timber frame built in place as well. So we'd little enough block work, thankfully, because it was a very complex build. So it worked very well. Again, this was a very non-standard site, so ICF was ideal, and with a portion timber frame as well, as I said. So, I mean, in a million years, I wouldn't use blocks on that site because half the project would have been handballing concrete blocks down there. And I think masons probably wouldn't have worked on it because it was so complex. So the access makes a huge difference, the complexity of site. So these are very simple questions, but they don't have simple answers because there aren't simple answers. I mean, every project is different, every house is different, every site is different, every project manager's experience, whether you're a self-builder or experienced contractor, is different. So and every budget is different. So there's no simple question or no simple answer to this question. The back of the envelope answer is block, but then it depends on your site and depends on you and your house. Hi Kieran, I'm looking to build a cheap rental property. What is the cheapest form of building? I'm hoping this isn't from one of the vulture funds that we're all trying to avoid coming in and destroying our rental market. Okay, back of the envelope answer. If you want to know what's the cheapest way to build a house, think of what affects a house. I mean, what affects a house is the scope of works, the complexity of a project, and the size of a project. So if you're building a cheap rental property, I'm sure you've worked out the size that works best for you in terms of the amount of bedrooms and everything else. So look, I presume you're keeping the size at a reasonable size that works for you. The complexity of the house, you don't want complexity if you want a cheap house. The cheapest house you'll build is a square or a rectangle. So don't get into L's, don't get into T's, don't get into U's, don't get into H-shaped houses. So forget all that. Your floor plan is going to look like a matchbox on its side. The cheapest roof you'll use is an A roof, probably trussed with a tile on the roof. PVC fascian soffit, double glazed PVC windows, sand cement render on the outside. You're probably pumping your cavity, and you have a timber joisted floor on the first floor and a concrete floor on the ground floor. In terms of the external envelope, I would be using blockwork. Again, I'm assuming a flat site. If you're building a cheap site, if you're building a cheap house, you need a flat site because the last thing you want to do is get into complexity on the site. So I would be using block on the inner leaf, pumped cavity, block on the outer leaf, and keeping it very straightforward. And that will give you a cheap house. I can't guarantee it'll give you a great house, but again, you're into the rental market. So look, you're probably just putting all this on a spreadsheet and hoping a nice magical figure arrives at the end for you. But that is probably the most cheap house you'll build. I mean, look at the best way to. I mean, look at developers. They build loads of houses that are exactly the same and they're very straightforward shape. That's because it costs less to do, and they can sell them at a reasonable price. And if someone wants to build on a fancy extension, they can do that afterwards at their own expense. Developers are using a little bit of timber frame now, I've noticed in the last few years, because I suppose they get things done quicker and they have interest roll-ups on their loans and everything else, and they can get their loans repaid quicker because they can get the houses sold quicker. So even though it's costing them a little bit more, I would have thought, unless they're getting a great deal in bulk from the timber frame company, and maybe they are, it means they get their loans repaid quicker, so they're paying less interest, so they're probably balancing the books there. I'm sure they are. But for a one-off builder, I would have thought if you're up for the challenge and you're set up for it on site, then block work is probably the option for you. So the next question is from Frank Bergen. A 1970s bungalow, block walls, and building an extension. What would you recommend? Funnily enough, it brings me back a little bit to something that was on in the Irish Examiner recently. I remember I got married in the year 2006, and at the time we were renovating and extending not a 1970s bungalow, but a 1980s dormer bungalow. And there was an architect in Cork designed the extension, a very contemporary extension. It was the very beginning of when people started to build extensions that looked nothing like the house. So this was a really radical extension. It had Valencia slate on the ground floor. It had zinc on the first floor. It had a steel structure with glazing on three sides out one side, and it had cedar box out on another side. And it had a cedar louvered monodirectional window. So, I mean, it was ticking all the boxes in terms of complexity, in terms of expense, and in terms of architecture and feature. Uh, None of this was block work. A little bit of block work behind the Valencia slate, but the rest of it was timber frame and steel frame and glass. So none of these series of extensions were made to look anything like the existing house. And in fact, they were there to compete with the existing house and add architecture to a house that had little or none at the time. But people have moved away a little bit from that now. I suppose I like to wear a variety of different hats in my role. Sometimes I have to kind of lean into the architectural field, the engineering field, the quantity surveying field, the building field. Um, as an architect, you might look to make a statement with your extension if you have the budget for that, because it's a discretionary spend. In that case, you might be heading down the road of using more of timber frame because it's a bit more dynamic in many cases with block work, and you can get a bit more contemporary in your design. The builder in me would like to see you use a very similar setup to the existing house. So the existing house is block. I would use block. If you find yourself leaning towards externally insulating the existing house, you could use a 6-inch block or maybe a block on flat on your extension so that you can externally insulate the extension just so that you have one consistent insulation throughout the house on the ground floor particularly. And that's what I did in my own house there. I said we built on a series of extensions there last year. And the existing house was an old kind of funny setup actually. The house is down near the coast, so the existing blocks, it was built in the 1950s. The existing blocks were built from sea sand, as I understand it. So we actually use a kind of a block on flat system for the extensions because I wanted to keep the external insulation running out over the extensions and the existing house, just so I wouldn't have any thermal bridging issues or detailing issues because I had one continuous wrap. But that's just this extension. It would be slightly more cost effective to actually pump the cavities of the extension if it's a big extension, because external insulation, whereas it's a great way to insulate the outside of a building, you get a lovely acrylic render finish on the outside as well, which looks great, and it's pre-colored and very robust. It is the most expensive way to insulate your building as well, but it has the benefits of your dew point on the outside, so you don't get condensation issues because the wind blows off the condensation. It also, having block work on your extension will also mean that structurally it's very similar to the existing house. So there are fringe benefits to all that. But in truth, you could use timber frame, no problem. You could use steel frame, no problem. It's just a little bit simpler if you stick with the existing structure, which is block work, as you say. And so our last question today is a real blue sky type question. If you were personally building a home for yourself, what wall structure would you use and why? Okay, so to make this a little bit more blue sky again, let's just pretend there's no budget, right? And I can guarantee you, if I was personally building a home for myself, there would be a budget. But supposing there wasn't, and let's just open it out a little bit to give you a little bit more of a sense of the options here or why you might do certain things. I suppose if I was building a house for myself from scratch, which I might add I've never actually done, I've always ended up renovating a house more just because that's kind of where the locations worked. Because it's harder to get a new house in a really good location because all the good locations have been built on, and those that haven't, you won't get planning on because they're kind of protected now by the local councils. If you were building a house from scratch, there's a few ways of looking at this. I mean, I suppose the cleanest way of insulating a wall is to externally insulate it. Now, as I said before, it's the most expensive way to insulate a wall, but it is the cleanest way to insulate the wall. And when it's finished, it looks lovely because you've your acrylic render on the outside. But it is also the most expensive way to insulate your wall. But it also means you're looking at a block on flat or maybe even a 6-inch block single leaf wall, which is going to throw up a few interesting details around your windows and structures like that. And your heads above your windows will want to be wider. They'll either be 6-inch or 8-inch heads. So it throws up a few kind of unusual details. But the walls are stronger because you can put kind of precast concrete slabs on the first floor without any difficulty on a 6-inch or a 215 mil wall. So it gives benefits that way. Now, if I was building a house, and I'm trying to picture what kind of house I'd build, but it definitely wouldn't be one big square of a house. So I'd probably have it broken up a little bit. I'd probably have a steel structure up on the first floor somewhere because the first floor and the ground floor would be two different things. I mean, if you someone told me before that the best way to design a house is design your ground floor and wrap it up. Design your first floor and wrap it up. So when I say wrap it up, I mean just draw out the rooms that you want, orientate them the way you want them orientated. So your living space is facing south, your front door consequently is probably facing north, and your other rooms then are kind of a variety of this. Your utility room might be on the east, and your living room with the lovely evening sun might be on the west. Your first floor, then you would typically have your bedrooms facing east, south, and west, but not north. And you have as little as windows as you can on the north. So your first floor and ground floor, because they're two very different floors doing two very different things, will be a very different shape. Where am I going with all this, you might ask? The reason I'm saying all this is because your ground floor and your first floor will be two very different shapes. So structurally, they'll sit on each other very different ways. It's not like a square house where the ground floor and the first floor are sitting neatly on top of each other. You might have overhangs, you might have flat roofs, you might have roof gardens or balconies or verandas or what have you. So you're getting complex, you're getting a complex structural arrangement, in which case you're putting a lot of steel into your building, and you're putting, then your masonry moves up onto the steel. No, so if all that's block work, fantastic. If it's all external insulation, fantastic. And if budget is of no consequence, then you'd be steel, you'd be block on flat, you'd be external insulation everywhere, and it is the most expensive way in this particular instance. You could argue the best way, perhaps, depending on how you measure best. But it'd be a nightmare to build it, and environmentally, you're spending a fortune on all these products as well. In that particular instance, I probably even lean a bit more towards a timber frame structure in that particular instance, because it's just getting a little bit easier to build, the builder in me, and a little bit quicker. But if expense was no object and the timescale was no object, then it could very well be block work and external insulation. I've seen that. We built a house years ago. There was a strong budget for the house, so to speak. And even though they could have saved money with the block work inner leaf, block work out leaf, pump the cavity, or use rigid insulation, they went with the external insulation and the block on flat. I remember looking at the amount of blocks that were being laid. It was frightening. I mean, you when you see mason build block on edge, you can see the walls moving up quite quickly, because you're every time you lay a block, you're up 400 odd mil. When you're block on flat, every time you lay a block on edge, every time you lay a block, you're 215 mil higher. When you're laying a block on flat, every time you lay a block, you're only going up 100 odd mil. So it goes up at half the speed, and the amount of truckloads of blocks that arrive on site is frightening. It seems a bit over the top to me, but it does give the benefit of the external insulation on the outside, the additional structural strength. I don't know. If it was me, I don't know if I could actually stomach having that much block on flat on a house. Truthfully, so maybe I'd probably do a little bit of timber frame. So a very hard question to answer, and I may not have answered it, but they are my thoughts, funny and all as they may be. So that is the end of this particular podcast. I hope it's been of value to you as you consider the walls of your house, the frame of your house, be it masonry, blockwork, be it ICF, be it timber frame, or steel frame, or a variety of other products that are available now as well. And there's all different ways of cladding these walls, as we know as well. I hope this has been of value to you. If you're at that stage in your project, I hope you've learned a little bit from today's episode. If you have any further questions, be sure to send them in to me at Kieran KMC on Instagram. I answer questions regularly, or as regularly as I possibly can. If you're enjoying this podcast, please leave us a star rating wherever you listen to your podcast. We're on Apple Podcasts, we're on Spotify, of course, we're on the Built Around You YouTube channel for the video version of this podcast. So I hope you found this podcast of value. I hope you learned a little bit about walls. And don't forget, we release these podcasts every Sunday evening at 8 p.m. So until next Sunday at 8 p.m., see you then.